So good day everyone. Today we will be having our video assignment number 2 that talks about or has AC circuits problems in enhancement course number 1. So let's start. So the first problem here. So the first problem is number 3. 3 parallel branches respectively contain R is equal to 300 ohms, L is 0.5 hertz, and C is 10 microfarad. Given the voltage V is equal to 200 sine 1000 T, determine whether the total current lags or leads the voltage and by how much. So we have the choices here. Letter A is 53.13 degrees lead. Letter B is 67.4 degrees lag. Letter C, 53.13 degrees lag. And letter D is 67.4 degrees lead. So first, let us identify the given. So the given are the voltage, which is 200 sine 1000 T, and the resistance is 300 ohms. Our L is 0.50 hertz, and our capacitance is 10 microfarad. For the solution, so the formula that we'll be using are the following. So the first is the formula Vt is equal to Vm sine parentheses so the formula Vt is equal to Vm sine parentheses omega t. So our Vm is our maximum voltage, which is the 200, and the in here our omega here is the 1000, like in the given value. So we have here the Vm is 200 volts and our omega is 1000. Then the formula for this is 2 pi f. So since we already have our values for the omega and the 2 pi, we will be solving for our frequency. So the formula for the frequency is omega divided by 2 pi. So in solving this one, we'll use our calculator and divide this 1000 divided by 2 pi. So we have the answer of 159.15 hertz. So that is for the frequency. So next, let's identify our XL. So the formula for our XL is equal to 2 pi f times the L. Then since we already have the given values, we'll just substitute. So we have here 2 pi times the f, which is 159.15 hertz, and the L is 0.5 hertz. And then let's compute it using the calculator. So we have here 2 pi times 159.15 times 0.5. So we have the answer of 499.98 ohms. So that is for the XL. So for the XC, we have here the 1 over 2 pi FC. Sorry for that, this is C. So FC. So since we already have the given values, we'll just substitute. So 1 over 2 pi times the frequency is 159.15, and then our C is 10 times 10 to the power of negative 6 farad. Since it is micro, so we have here negative 6. So compute it using the calculator, we'll have the answer of 100 ohms. So that is the value for XL and our XC. So to get the value for our impedance, we have here the formula 1 over the square root of 1 over r squared plus the quantity of 1XL minus 1 over xc quantity squared. Then since we already have the values, we will substitute. So our r is 300, so 1 over the square root of 1 over r squared, which is 300 squared, plus the 1 over xl, which is 1 over 499.98, minus the xc is 1 over 100, the quantity squared. So if you compute it in our calculator, we'll have the impedance of 115.3855986. So first, we already solved for the impedance, so we will solve for our G. G is 1 over R, so the resistance, so 1 over 300, then it is equal to 0.003333 S. Then to convert it into ms, we have here 3.33 ms. Then the BL is 1 over XL, so 1 over 499.98. It is equal to 0.002 S or 2 ms. Then the BC, we have 1 over XC. Then the XC is 100, so 1 over 100 is 0.01 S or 10 ms. Then the Y is 1 over the impedance, so 1 over 159.39. So we have here 0.00866665 and so on. And we convert it to ms, so 8.6659 to 818. So get our phi. So we have here cosine, arc cosine G over Y, then substitute. Our G is 3.33 ms and our Y is 8.66592818 ms. Then compute it using the calculator, we have the answer of 67.4 degrees for the phi. So the answer, and since we have here the note, if the XL is lesser than our XC, we have lagging, and then the leading is XL greater than XC. So since we have XL greater than XC, we have leading. So the answer is, so therefore the answer is that third D here, 67.4 degrees lead. Next is for the number 8. So number 8, a non-inductive reactance, a resistance, is in series with a condenser takes 7 amperes and absorbs 300 watts. When connected across a 110 volts, 25 hertz mains with 25 hertz mains, that is the frequency, what non-inductive resistance must be connected in the series with the circuit in order that it may take the same current from 110 volts, 60 hertz supply. So the choices are A is 8.38 ohms, B is 6.12 ohms, C is 6.87 ohms, and D is 7.72 ohms. So the given are, we have here the current of 7 amperes, the power of 300 watts, and the first source is 110 volts at 25 hertz. And then we have the same supply here, another supply here with 110 volts at 60 hertz. So the solution, we use the formula P is equal to I squared times R. So since we are looking for our R, or the non-inductive reactance or resistance, we have R is equal to power over I squared. Then 300, which is our power, over 7 amperes squared, we have 6.12 ohms. So the answer is letter B, 6.12 ohms. Next is number 44. A series circuit with R is equal to 2 ohms and C is equal to 200 picofarad has a sinusoidal applied voltage with a frequency of 99.47 MHz, we used to call megahertz. So we use this MHz to, it is read as megahertz. And if the maximum voltage across the capacitance is 24 volts, what is the maximum voltage across the series combination? So we have here the choices: A, 24.74 volts, B is 25.63 volts, C is 27.21 volts, and letter D is 20.26 volts. So Identify the given. We have here the resistance of 2 ohms, the capacitance of 200 picofarad, the frequency of 99.47 megahertz, and the voltage maximum or the maximum voltage of capacitance is 24 volts. So to solve this, we have here the VC. The formula is VC is equal to I max times C. So since it is already given, we have 24 volts. So we have here, we will be solving for the I max. So the VC is 24 volts equal to I max times the C, which is 200 picofarad. So we have here 24 divided by 200, cancel here, cancel. So we have I max of 1.2 times 10 to the power of 10 amperes. And then the VR is I max times R. So VR is 1.2 times 10 to the power of 10 amperes times 2 VR. Yes, the same. Then we have here VR is 2.4 times 10 to the power of 10 volts. And then we have here for the total voltage, we have here the series combination. So this is the maximum voltage. So square root of V squared, the VR squared plus VC squared. And then 2.4 volts squared plus 24 volts, 24 squared is 24.11970,149 volts. So since the closer answer for me is letter A, so we have here the answer is letter A, 24.74 volts. I'm not sure if my answer is correct, but that is my solution. And yeah, so next, number 78. So we have here the current drawn by a 120 volt electric fan is 6 amperes at a power factor of 0.5 lagging. The fan is to be supplied from a 220 volts AC mains. Determine the resistance to be connected in series with the fan so that rated voltage will be impressed across it. So letter A, 22.32 ohms. Letter B, 34.42 ohms. Letter C, 24.63 ohms. And letter D is 25.54 ohms. So the given, we have the voltage of 120 volts, the current of 6 amperes, the power factor of 0.5 lag, and the 220 volts mains. Solution is E is equal to IZ. So I is our current and our Z is our impedance. So we're solving for this. Z is equal to E over I. We have E of 220 here for the mains. So 220 or 220 volts over 6 amperes is 36.67 ohms. So since there is no the same value for the choices, so I chose letter B, 34.42, since it is closer. So therefore the answer is letter B, 34.42 ohms. So again, I'm not sure of my answers, but this is my solution. So number 95. So a series RC circuit with R is equal to 10 ohms has an impedance with an angle of negative 45 degrees at f1 is equal to 500 hertz. Find the frequency for which the magnitude of the impedance is twice that at f1. So we have here the choices: A, 182 hertz, letter B, 178 hertz, letter C is 212 hertz, and letter D is 189 hertz. So given, we have here the FC1, which is 10 ohms, and the F1 is 500 hertz. So the solution, we have here Z1, which is the angle of negative 45, is equal to 10 minus JXC. So since we already have the value for XC, so we'll just substitute. So Z1 is equal to 10 minus J10. So to solve for this, using the calculator with the mode of complex, we have here Z1 is equal to 14.14 ohms. So since the problem states that the magnitude of the impedance is twice, finding the frequency for the magnitude of impedance that is twice, so we will multiply the Z1 of, which is the 14.14, So we will multiply our 14.14 times 2. So since it is twice, so times 2. So we have here tan minus jxc2 is equal to 14.14 times 2. So we have here 28.28. So and the angle is 0. So tan minus jxc2 is equal to 28.28. And then we will solve for the xc. So we will have the answer of the square root of 28.28 squared minus 10 squared. So our xc2 is 26.45 ohms. So since xc is inversely proportional to our frequency, we have here xc1 over xc2 is equal to f2 over f1. So substitute the values. We have xc1 of 10 here. Then xc2 is 26.45 over frequency 2 is the missing, and the f1 is 1200 hertz. So cross multiply 10 times 500. 10 times 500 is 5,000 divided by 26.45. We have the answer of 189.04 hertz. So in the choices, we have here 189 hertz. So therefore, the answer is letter D, 189 hertz. So next number is 102. A two-branch parallel circuit with impedances Z1 is equal to 4 angle negative 30 degrees ohms, and Z2 is 5 angle 60 degrees ohms, has an applied effective voltage of 20 volts. Determine the total volt ampere drawn by the circuit. We have the choices. A is 132.4. Letter B is 147.5. Letter C is 128.1. And letter D is 152.8. For the given, we have here 20 volts for our E, our voltage. We have Z1 is 4 angle negative 30. And letter Z and the Z2 is 5 angle 60 degrees. For the solution, we will solve for the total impedance with the formula Z1 times Z2 over the sum of Z1 and Z2. So substitute the values. We have here 4 angle negative 30 times 5 angle 60 over the sum of 4 angle negative 30 plus 5 angle 60 degrees. And we have the answer of 3.123475238 angle 8.66598 degrees. So that is for the impedance. Since we are solving for the total volt ampere, so we have here S is equal to E squared over Z. So our E is 20 volts. We have here 20 squared over the impedance, which is 3.123475238 angle 8.66598. So the answer is 126.602540 minus 19.282323I. Then solving it from the rectangular form, so we have here 128.1 angle negative 8.66. So since we have here 1.128.1, so therefore the answer is letter C, 128.138. So next, for the number 27 and 61, I don't have the solutions because I don't know how to answer this one, but to be honest, I am searching for some same questions, but I didn't have enough time and I didn't see any similar questions. So, but I have I've seen an article that has this question and has an answer but with no solution. So I'll just state it that in the problem 27, an impedance coil is connected in series with a condenser across 220 volts, 60 hertz source The circuit absorbs 800 watts and a power factor of 0.40 lagging and is so adjusted that the voltage across the condenser is 350 volts. What is the voltage across the impedance coil? So these are the choices: A 201.6 volts, letter B is 544.5 volts, letter C is 360.8 volts, and letter D is 558.6 volts. So in the article that I've seen, the answer is letter D, which is 558.6 volts. So these are the given, and the answer is letter D, 558.6 volts. And for the number 61, a resistance and a condenser are connected in series across 220 volts. 60 Hz means what is the capacitance of the circuit when it is adjusted to take 250 watts and a power factor of 0.20? Same as the 27, number 27. I don't know what's the solution and I don't know how to answer it, but I have seen an article and I'm not sure if it is correct, but the answer is letter A, 69.9 for the capacitance. These are the given and the answer is letter A. So that is all for my questions, 8 questions for the AC circuit problems. And again, I am Princess Maila Cubayo, BSAE. Thank you.